Okay, this is our second example of finding critical points. Remember what we need to do. We need to take both partials, set them equal to 0 and solve, and make sure that they're always defined at those points. So meanwhile, here we go. I'm going to take the partial derivative with respect to x. What am I going to get here? I'm going to get 3x squared plus 3y. That's equal to 0 like that. That's always defined, so all I have to do is set it equal to 0. If I take the partial with respect to y, I get 3x plus 3y squared. That's also always defined, so I can, when I'm looking for critical points, I only need to set those equal to 0. Now I need to solve one or the other. What I'm going to do is look at my first equation, and I'm just going to solve for y. I'm going to get y is equal to minus x squared. And then what I'm going to do to that is plug that back into my second equation, so I get 3x plus 3 times minus x squared squared like that equals 0. Simplifying a little bit, I'm going to get 3x plus 3 x to the fourth equals 0 like that. Remember not to divide by variables. You want to factor everything out. I can take out a 3x. What's left is 1 plus x cubed like that. I set it equal to 0. I'm multiplying two things together to get 0. Either the first thing is equal to 0, and that just tells me that x could be 0. If I set the second thing equal to 0, I would take the cube root of both sides, and I wind up getting x equals negative 1. So it looks like at the moment, I want 0 and negative 1, right? Yes, 0 and negative 1. All right, here we go. Looks like there could be two critical points. Now how do I get the second, the y value of the critical points? I'm going to just take this and plug it back into here. I can get y equals minus 0 squared, so that's just 0. Or I can get y equals minus, and remember, be careful about this, minus 1 squared, and that's a minus 1. So here we go. There are two critical points. And I'm just going to say CPs for critical points. The first one is just 0, 0, because the y value is 0 when x is 0. The second one is minus 1, minus 1, because the y coordinate was minus 1 when x is minus 1. So there are two critical points that we're going to actually have to try to use the second derivative test on.